So 4 years ago today, tell us a bit about the company, how it got founded, and what exactly you do there.
Actually, we founded our first EV company in 2010 in Aachen, which was street scooter. And that we started a small city car, and then we had a cooperation or a demand from Deutsche Post. And then we converted that concept into a parcel delivery car. And finally, Deutsche Post DHL got so excited that they bought the whole company. That was in 2014. And we thought we haven't done the whole way already, or perhaps the message was not completely understood in the branch, so to say. And so 6 weeks later, I founded with the next team, e.GO Mobile AG, to provide first step an affordable EV car, which we are presenting at several locations here on the fair, which starts with 16,000 euros in the basic version, and in the 60 kilowatt version, it's a 19,900 euro car. Completely different build than usual cars, and that makes it possible to have reduced R&D costs and a significant reduced bill of material base, which makes it possible to earn money on such a low price level.
And earning money is really the necessity we're all faced with in order to develop this technology. We know, looking back, that there's always been this philosophy of the perfect marriage between hydrogen fuel cells and batteries. A lot of people think it's either or. It's, we're going to win. Is it going to be the battery fuel car or the fuel cell car? Could you tell us a bit about why this combination is so optimal, why batteries and fuel cells work together so well?
I would say both is difficult. I think we tried too much either or. Either I build an EV car, and then it has to be a significant big battery to get a reasonable range comparable to combustion engine cars. That is not a good idea, because batteries are expensive and they remain expensive the next 10 to 15 years, at least 10 to 12 years. And so that it is not possible to provide a passenger car just on the battery basis with comparable ranges and affordable prices. And then we have the other exercise since more than 15 years, even in passenger cars, is saying, well, we are not building an electrical car, we are building a hydrogen car. And everybody of you knows that's an electrical car. But this normally is provided with just a very small battery, just for recuperation and not for driving out of that battery. And that makes it a very complex hydrogen or fuel cell system, because it's now load variable and it has to have the full peak power of the electrical engine so far. And that ends up in a passenger car above 20,000 euro per system. And if you compare it with a nice combustion engine in that range, which costs 1,500 euros, we never make that battle. So either or was not the right assumption. And the intelligent combination of cars with a small battery and a small serial range extender, in terms of a serial plug-in, which means range extender system, allows to have, in our big people mover where 15 people fit in, which is a 2.8 ton car, we just have a 35 kilowatt hour battery. The electrical engine is powered just by that battery, and peak power 150 kilowatts is sufficient to be sourced from that battery. And on the other hand, we will have a 25 kilowatt hour fuel cell system, which is stationary and which is extremely to the spot industrialized. And that makes it affordable nearby. And because we couldn't buy that, we finally not only stopped with developing this type of car and that people mover, we said one big portion of the solution is if you can start with a fuel cell system and you have not all problems at once: costs, package, and system solution. So we have a range extender system solution. We have, of course, the cost issue. We want to provide a system below 6,000 or 7,000 euros in that area. but we have no package problem, because that would be not possible to do that in a passenger car, because then you have to have the very condensed systems, including the high pressure tanks. And if you combine that, even on a low level of 25 kilowatt hours, you are far above 12 or 15,000 euros, and then there is no economics possible for that kind of or type of car.
So one big argument for your technology is obviously the price. I think just to pause for a second and make sure we're stating the issues. So I bought a new laptop and I discovered the battery, it can be quick charge, which sounds great. The first thing you learn, though, is quick charging batteries also deteriorates the battery life. Mm-hmm. We're talking about the capex of batteries in a battery vehicle. The second thing is, those devices don't like to be discharged completely. Mm-hmm. When we get to the way the two technologies cooperate, mm-hmm. I find the word range extender actually avoids mentioning that we're improving the function of the battery by combining those two technologies.
Very much so. I mean, I'm now driving hybrid cars for 4 or 5 years. And the nicest thing with any kind of hybrid cars is that you use the battery much, much more than in a pure EV car. Because you drive from 100 or 90% down to 10%. You don't do that with a pure battery-driven EV car. So it's much more sufficient to operate on basis of the battery, but you use a small battery much more. So this is, in ecological terms, I would say even the only really reasonable usage of batteries. And only that range extender, and then the most ecological sense-making system of range extending is fuel cell. And the fuel cell doesn't like load changing and various demands on power. So if you can put it on an operational point and optimize it to that, you have with cooling, with control, everything can be much, much easier and cheaper. And so you get really a nice and affordable hydrogen system, fuel cell system, and you can remain with a small battery in the overall powertrain. For our big bus, which, as I said, is a 2.8 ton bus, we will in total be far below 10,000 euro for that system, and it's a full ecological system. You have full range because you tank in 5 minutes whenever you need that, and the power of the fuel cell system is exactly that level what you in average of load need to fill up the battery to charge the battery while driving.
There's so many elegant details in that. I love the fact that when you step on the gas, you can actually draw energy for quick acceleration from two sources. Whereas if you have either battery or fuel cell, you have to provide a large enough element to give that boost to your acceleration from only one source. So it's
but actually, you design it that the battery could do the full acceleration on its own. If you test one of our small cars, e.GO Life, well, it's a very small and, as I said, very cheap car, but it's a Porsche killer. You know, at every traffic light, it's a Porsche killer because you can accelerate like hell, and this influences the behavior of Porsche drivers in the future, you know.
So behind the scenes, you're also working on manufacturing capacities, how to get these things in an affordable manner to the market. What's changing there for you?
Well, actually, we started that. Actually, I'm not a car guy. I'm a kind of car guy by emotion.
All guys are car guys.
Okay, but I'm a professor in production engineering, and so our first view is always, how can we produce it cheaply? That's why we changed completely the body design of our cars, which is an aluminum space frame design, not a self-carrying body, and so we need extremely less capex for tools and dies, and for no painting. We have no painting. The exterior comes in nice shiny plastics in that color without any painting. And the same thing that we did with e.GO Live and that we are preparing for the most affordable mover or a minibus is now our attitude for our approach for the fuel cell system. Actually, the fuel cell system contains out of, let's say, 9 significant components. And 8 of them are not industrialized so far. Really surprisingly, none of these components are industrialized in what we as production engineers would call an economies of scale optimized production. That comes, of course, because of volumes are low, and normally you have big applications in stationary applications or in buses or trucks. That is nice, very appropriate, but normally comes in hundreds of numbers of volume and not in 10,000s. But we need 10,000s to achieve some economies of scale. And then we have to start with decompression, even with the tank. Who said, I really have to blame that, who said that 700 bars is a smart solution for tanks of hydrogen? Somebody said that, but this is very cost efficient. We won't do that, because then a tank of 2 kilograms will cost minimum 2.5 or 3,000 euros. My whole system should cost that much in that range, or maximum double of that. So we should focus on simplicity, on affordability, on economies of scale, in tanks, in decompression, in cooling, even building systems which have no DC-DC changer in terms of we just should end up with current that we need for the powertrain and not convert it into higher voltage. We should have a bipolar plate production, which is really a serious production system. We should have an assembly of the stack, which is really an automated, industrialized production. And if we put all that together, you can come really down from systems, I must admit, in the range of 100 or 120 kilowatt, what you see in some of the passenger cars, down to a system between 20 and 30 kilowatt. But we come down from 20,000 euro down to 5,000 or 6,000 euro. And then we are in the game. Then we have the most ecological, and I must also say, the most fun-making cars. You know, we have to sell all these cars coming up to people who are buying new cars, which are typically car guys. And they are not only coming from rational attitudes, they're coming from emotion, from fun. And so it must be a fun car as well. And EV cars can be the most fun cars you can believe or imagine. And so in combination with fuel cell, that's it.
We need to trademark that word Spaß factor, the fun factor for the cars.
Right, very much so.
Super important. There's so much to talk about here. We need the volume, of course, to make any fuel cell car affordable. This already has a market, niche markets like forklift trucks. What is your first market target? Is it delivery vehicles, buses? There's all sorts of applications potentially for the technology you're offering. What are your first large markets? What are you going to be addressing?
Yeah, first is we want to show everybody that this is really an intelligent combination, and so we show that in our people mover, our bus. Where's our booth from here?
Right over there.
This way.
B45.
Thank you. That was the Edward part. Thank you. And we plan to build 30,000 of that bus, and I hope that we, as early as possible, beginning in 2 years and 3 months so far, with our SOP of that series system, that we can build in the first run between 5,000 and 10,000 units for our own use. And we didn't do that in e.GO Mobile AG. Actually, for that purpose, we founded in last autumn the e.GO Rex for range extender GmbH, to be ready to sell that system to anybody who wants to implement that in his system. And of course, our system will be easier to implement in vans or buses or small trucks, where it makes very much sense in any application setting. And later on, we will be able to condense it even more, that at least mid-sized passenger cars could carry that as well. but we want to see or provide volume, and we can provide the first volume of the first 10,000 systems in our own cars. And in that period, I think everybody can see that this is really a smart solution and can be fitted, and even as you said before, can be retrofitted in cars who have a package opportunity where you can fit that in. You can see that in our People Mover, we retrofitted our first set of fuel cell system in that car. In the near future, when it comes to series production, we won't do that as a retrofit, but it shows that this is easily possible.
This seems to me the logical future. You buy an electrical car because there's places to tank it up at home, for instance, but when that becomes prohibitively expensive, and of course the price of hydrogen is dropping, you can switch and remove the battery, a large part of it, and put in that extender.
Right.
On that note, so we had a decision on yesterday. The Ministry of Transportation, Schuh, announced that he was going to pour €1 billion of our taxpayers' money into the infrastructure for electro cars. Is Schuh bescheuert? Is he crazy?
No,
is it a good idea?
No. Schuh is not bescheuert. No. I think it's very necessary that the government that there's some public-funded first investment in infrastructure. And I think it's not only that we still have a bit to catch up with charging stations. What we have to have as quickly as possible is at least 1 or 2 or 3 stations for every small city, of course much more in bigger cities, where the investment case is not very clear for potential investors right now for the time being. And that whenever you want to change something into a better world, then the state should help in a catalytic way and invest that. And I think, well, in gas stations, we have 8,000 gas stations in Germany. We would, in the end, need just about 800 to 1,000 hydrogen gas stations. That would be sufficient. And so we need to boost that in the next couple of years from, let's say, 200, which are coming up right now, to 400 or 500. And this could be done with this €1 billion of euros more or less successfully. So I'm very happy with that announcement, because it needs the confidence of customers who are now already very interested, what we all feel, in fuel cell systems. Even though they are too expensive, a lot of people would invest more than the business case would really stand for. But if they have no confidence that there are sufficient number of gas stations, hydrogen gas stations, they wouldn't. So this announcement is even worse to help that people start to decide to buy fuel cell cars.
And one way or the other, cars with electric drivetrains in the future, let's hope they'll all be retrofitted with your technology, because that would be the key to expansion. We have time for one brief question from the audience, if there is a question. Hope it's a short one.
Thank you. I would like to know what would be the investment cost for a hydrogen let's say, gas filling station. But if you have a look for the buses, I think that's quite interesting. And if you have a look as well on infrastructure for, let's say, waste collecting cars, that could be extremely interesting if they would be equipped with hydrogen motors.
Well, if we are talking about gas stations which would be sufficient for our mover acting as a public transportation on-demand bus or so, the direct investment is around 1 million, 1.2 million only. If we take normal gas resources, of course it would be even much nicer if we have ecologically gained hydrogen. Then it becomes significantly more expensive. So a lot of people think it makes only sense if we have it combined with renewable energy sources to gather that fuel cell. I would say let's get started. Let's get started to have gas stations so that people start to invest in that vehicle and in that usage. And if possible, we should additionally invest in renewable, sourcing process of that. But to get started and to get a significant population of gas stations anywhere in Germany at least, or even better in Europe, that will be the biggest point. And so that is the good point with the announcement of Mr. Scheuer.
We're on the right road. And of course, we were mentioning in the pre-talk, they've already discovered that it's cheaper to install an infrastructure for hydrogen fuel cells. Green hydrogen is dropping in price. So everything's on path. I have been talking to, and I'm really thrilled about this development here, because finally someone's getting into the either-or debate and offering a transitional technology that will work in both environments is fantastic. So I've been talking to Dr. Günther Schuh, who's CEO of e.GO Mobile. I hope to see you back here next year, and I hope the sales go well. It's been a pleasure.
Thank you very much. It's a pleasure
you.
to me. Thank you very much. Thank you very much.
Thank you.